as I explained before, the first phase of the design is the definition of the right model of the AP. For example, in the universities, going back again, because this is a typical case for us, the best model is a 4x4. In Wi-Fi 5, we have the Arista C130. In Wi-Fi 6, we have the C230. And this is ideal because this one has 4 spatial streams per radio. So this product is very good in this environment. In the case of a small space with few clients, we can use probably the C100 or the C110 in the case that the client requires permanent width solution or performance measurement, okay? The second thing is here, there are some implementations that are not complex. Where we're using general building data if it is an isolated location and there are not a lot of walls or elevators, we can identify easily which are the main coverage points and where the appropriate locations for the APs could be. So the message here is we don't need to be a radio frequency experts in order to define some specific things in the locations that are not so complex, okay? For medium and high complexity projects, the recommendation is use a tool like ICAHAU or Air Magnet. So the main idea is to use ICAHAU at the design phase, basically in order to provide seamless roaming, as we are saying here, in order to identify the areas of attenuation, the noise sources, and identify also the interferences, or the Wi-Fi interference and the not Wi-Fi interference. There are many things, as you know, that can generate interference to the Wi-Fi systems. As I said, high voltage rooms, air conditioning systems too, also because some of them can work in the same band, in the 2.4 band, or elevators, okay? Some of them can generate co-channel interference, and for this reason, basically, ICAHAU says that there are 3 different kinds of site survey. The first one, the first 2 are basically the most common. The passive, this one is on-site survey, the passive one. If there is no existing Wi-Fi, an AP needs to be temporarily installed there in the environment, and the measurements of the room and surrounding rooms are taken to measure the actual signal coverage in the environment, okay? This type of survey is also used in order to find a third-party Wi-Fi system or non-Wi-Fi devices in the area so that the presence can be accommodated in the design, okay? The second one is the predictive. So this involves a mathematical model of the facility and a software package from ICAHAU. So the floor plans are loaded in AutoCAD or in PDF, so that we can define here in the tool the dimensions of the building, the ceiling, the different materials of the walls, the material constructions in order to have the attenuation and the reflectivity characteristics, okay? Finally, the last one that is not very common is the active, that is like a mix of the passive and predictive, okay? In the last session of this training, Chris explained it, and also Tom did, they explained it very well, the advantages and disadvantages of each frequency. As you can see here, in the 2.4 band, we have 3 usable channels, the number 1, the number 6, and the 11. But what happens if we want to use the channels 2, 3, 4, and 5, for example? So it is observed here that those channels will have an adjacent channel interference. Remember that this band, the 2.4 band, was the beginning of the Wi-Fi 20 years ago. It goes at lower signals and can go further. This was used in warehouses with the first generation of scanners. This band also was used 20 years ago in wireless phones, in microwaves. So there are many devices that can generate interferences here, okay? We can see here also in this side of the screen that the 5 GHz band is cleaner, is faster, and has a greater channel spacing. For example, here you have more space between the channel 36 and the channel 40, okay? So The only disadvantage of this band is basically that it does not go as far as the 2.4 band, okay? So many devices connect normally to the 2.4 because it's the frequency that can offer the best signal level. So the message here is that using ICAO, we're going to make a channel design in the two bands, in 2.4 and in 5 gigahertz, okay? Here you can see also that, for example, if you want to use a bandwidth channel of 40 megahertz in the 2.4 band, this can bring issues. And meanwhile, in the 5.0 gigahertz, you can have 20 megahertz, 40 megahertz, 80 megahertz. If you select the 160 megahertz, this can, the same thing, can bring more interference, okay? Also, this slide is important because you need to be careful on what devices are you going to use. I mean, your customers, okay? This is a famous site in the Wi-Fi community called Mike Albano, okay? So this site has all the details of which channels each device supports in 5 gigahertz band. So it is important because you need to take a look here and you need to make sure that you are not leaving out any customer devices that you are going to have in your network, okay? This slide is basically a list of all the things that needs to be validated and verified by a partner, usually to make sure that the quality of the installation and the design is correct. The first thing is to personally verify the installation and compare against the design document. The second thing is to check that the APs are installed at a suitable height and there are no obstructions. The next one is validate the cabling and the correct category of the cabling and certify the cabling using these devices, the Fluke devices. Also, it is very important that the coverage must be between minus 40 dBms and minus 60 dBms. The minus 50 is optimal. If you are getting this type of signal, minus 70, 80, or 90, so your user is going to have a very bad Wi-Fi experience, okay? It is necessary to validate also the roaming, that the roaming works well and the speed of the Wi-Fi is good and the applications are working correctly in each SSID. For cabling, as I said before, it is also recommended to use Cat6 at least, and also you need to check the fibers in the MDFs or in the IDFs, okay?